So ionic bonding was between a metal and a non-metal. Covalent bonding is going to be between two non-metals. They have a much lower electronegativity difference. There's less difference in how much they're pulling on their electrons, so electrons end up being shared. When we're writing our covalent Lewis dot structures, we're going to have to follow a few rules. So you want to go ahead and write these down so you've got them when we're doing our examples. You have to pick a central atom. It should be the least electronegative element. Unless your least electronegative is hydrogen, it's never going to be hydrogen. Arrange the other elements around your central atom, add in your electrons, and then make sure each element has 8. Unless we're looking at hydrogen, a group 2 element, or a group 13 element. Those are happy with less. We'll talk about that in our examples. For our first structure, we're going to look at CH4. So we said our first step is to pick a central atom. And we said our central atom can never be hydrogen, so that clearly leaves us with carbon. And so we've got carbon. Now we want to arrange our other elements around our central atom. So we're going to add 1, 2, 3, 4 hydrogens. Next, we want to add in the electrons, starting with our central atom. So we're going to add in carbons, 4 electrons, and then we're going to add in 1 electron each for each of our hydrogens. And so now, we're out of electrons because our hydrogens only came with 1 each, our carbon came with 4. And if you notice, we've got 1 pair of electrons between my hydrogen and my carbon. And this is a bonding pair. And so that is 1 bond. All right, now let's do the same thing with our H2O. We said we've got to pick our central atom, but it can't be hydrogen. So we're going to start with oxygen in the middle. Then we're going to arrange any other elements around. So we've got hydrogen and hydrogen, and it doesn't really matter which side you put those on. So now we're going to fill in our electrons. We're going to start with oxygens, 6. And I'm going to go ahead and put the single electrons next to the hydrogen, because those are the ones that are going to be involved in a bond. And it's always easier to set them up right the first time. Now I add in hydrogens, 1 electron each. And so now I make sure that everybody's happy. My oxygen now has 8 electrons. My hydrogen only has 2, but hydrogen's actually perfectly happy with 2, which is what we left off with on CH4 as well. So now in addition to having 2 bonding pairs or 2 bonds, we also have what's called a lone pair. A lone pair, also known as a non-bonding pair. These are electrons that are just hanging out. They're not involved in any kind of bond, but they're still there. So water has 2 lone pairs of electrons. We've got a couple more examples of covalent bonding because this is a little more complicated. Our next example is CH2O. We've still got to start by picking a central atom, and we've got more to choose from. We know it can't be H. We know we've got C and O. We want to pick our less electronegative, which is carbon. If carbon is an option, carbon is always a good central atom. We're going to start with our C first. We're going to arrange our other elements around. So we're going to have our O, and then we're going to have our 2 H's. So we're going to start by putting in our electrons for carbon. We're going to do 1 per side before we pair, for now. We're going to add in our 1 electron each from our hydrogens. And then we're going to add in oxygen 6 electrons. So we're going to put 1 there, 2, 3, 4, 5, 6. But what do we notice? We notice that neither carbon nor oxygen has a full set of 8. So now we can make what's called a double bond. If you ever have electrons left that if you ever have electrons left over, you can actually make extra bonds as long as it's the right kind of element. And so now, if I move these in, got another electron from oxygen. I've got another electron from carbon. Now oxygen is going to see 1, 2, 3, 4, 5, 6, 7, 8 electrons. Carbon's going to see 8 electrons. So now everybody's happy. This is called a double bond. There are 4 electrons instead of 2 electrons, so that makes 2 bonds. This is kind of a good time to show. We can also redraw this so we're not showing all of our dots. So we can actually draw this so that we just draw our bonds as lines. And so that would be C, double bond to oxygen, leave the lone pairs, bond to H, bond to H. And so each of these bonds equals 2 electrons. So remember that if you see it drawn the other way. You can also draw it that way. All right, our last example is BF3. We've got to pick our central atom. We know we want less electronegative, and fluorine is the most electronegative. Also, you only have one boron. So we're going to put B in the middle. We're going to put our fluorines around it. Then we're going to fill in boron's electrons. And then we're going to fill in all of fluorine's electrons. So we've got 7 on each. And so if you look, you notice that each of my fluorines has 8 electrons, but my boron only has 6. And what we'll actually find out is that elements in group 13 are perfectly happy only having 6 electrons. They don't need a full 8. And just like hydrogen is okay with just having 2 electrons, just having 1 bond. All right, so now you've got some guided practice. Try them on your own. Make sure you're using the right type of bonding.